Okay, I have started recording the class. Why it's not showing up in there? Previously, it was showing in there, right? Suddenly went away, right? Yes or no? No? Is there any connection missing from there? It was not working, sure, right? Georgi? Oh my goodness. If this is the scenario, then what should I do? Yeah, this is what you need to do. I don't know why. Huh. This computer can be. Oh. I did not disconnect anything. I just did what I did before. Okay, you can turn back, please. This thing is not working. So maybe you can bring your chair in there. Okay. Yes. Yes. You problem. Yeah. Okay. Problem. Oh, that's fine. Sorry. Yeah, will you sleep there, or maybe you can come in here. Come in. Yogi, you can come here. Yeah. Can you see that from there? Yeah. Okay. I will report it. Okay. So I updated this PDF. Okay. Did you see that today I uploaded it again? And then I added this code in here. This is the, are you seeing this R code? This 1, 2, 3, 4, these R code are for these 4 problems. Okay. These four problems, this is what I did by using the Python. But what would be the R code for A, B, C, D is mentioned in here. This is the A, B, C, D, like 1, 2, 3, 4. Okay. So this is the R code for these 4 problem, and these 12 problem R code are given in here. This is the R code for the 12 problems for these 12 problems. Okay. Clear, right? And then And then let us solve like few problems from each of these, okay? So you will get 20 questions, around 40 minutes to finish this exam, okay? 20 questions to finish this exam, you will get around 40 minutes. Now I want to click on their binomial distributions in here. I want to solve, let us 2-3 problems from there, okay? Let us solve 2-3 problems from there. So for example, 2, a pair of dice is rolled 5 times. So n equal to 5. Okay. If getting the product of 6 is considered as a success, find the probability of getting at least 4 successes. If getting the product of 6 could be obtained 6 times 1, 1 times 6. This is one way, right? Product of 6. And 2 times 3 and 3 times 2. This is the only way you can get 6, right? Are you saying the product of 6 is considered as a success, right? So that means 1 times 6 could be 6 and 6 times 1 could be 6. 2 times 3 could be 6. 3 times 2 could be 6. This is the only 4 ways you can get 6, right? So that is why 4 over 36. Are you seeing? Are you seeing it was written in here 4 over 36. Here it is written 4 over 36. Okay. So because this is the only 4 ways you can get the outcome from 2 die. So one die could be 2, another die could be 3, or first die could be 3, second die could be 2. First die could be 1, second die could be 6. First die could be 6, second die could be 1. That is the only way you can get 6. So 4 out of 36 sample point. If you toss 2 dice, how many sample points? 6 to the power 2 equal to 36, right? Are you okay, gentlemen? Are you understanding? So you understand why 4 over 36, right? Okay. Now I want what? At least 4 success. Okay. We find the probability of getting at least 4 successes. So at least 4 successes means this 4 or 5. Like this way. It is tossed 5 times. Okay. It is tossed 5 times, so I get 5 successes like that way. So if someone asks me to solve this problem, here is the thing. If I toss 2 die, I will get 1 1 1 2 1 3 1 4 1 5 1 6. Similarly 2 1 2 2 2 3 2 4 2 5 2 6 and 3 1 3 2 3 3 3 4 3 5 3 6. I will get 4 1 4 2 4 3 4 4 4 5 and 4 6. I will get 5 1 5 2 5 3 5 4 5 5 and 5 6. 6 1 6 2 6 3 6 4 6 5 6 6. So this is the one sample point when product could be 6. This is the another sample point whether product could be 6. This is the 2 3. This is the sample points where product could be 6. This is the sample points where product could be 6. So that means 4 out of 36 sample points. So P is the probability where 1 over 9. The probability of appearing one of the sample point is 1 over 9. So now I am tossing the 2 dice 5 times. So 2 dice 5 times. So our n equal to 5. Our small p equal to 1 over 9. What is the binomial formula? Binomial formula is x equal to x, and then I can write here n cx, and then small p to the power x, 1 minus small p to the power n minus x. And they are saying I am tossing it 5 times, at least 4. At least 4. So that means it should be p to p x greater equal to 4. So as I'm tossing it 5 times, so probability of x equal to 4 plus probability of x equal to 5. Okay. Now for the first time I'm writing it the formula and then also R code. Next time I am not going to write the formula. Instead I am going to write the R code so that I can save my time and discuss. Instead, I can discuss a lot of problems. Okay. So now if I want to write the formula is 5 choose 4 p to the power 4, which is equal to 1 over 9 to the power 4, and then 1 minus 1 over 9 to the power 5 minus 4, then plus 5 choose 5, then 1 over 9 to the power 5, then 1 minus 1 over 9 to the power 5 minus 5. Okay. This is the formula. When we are a student, we solve this problem by that approach. But as you are now in a very advanced time, so you have to write it in D. If you want to write it, D binom, I think 5 choose 4 and then 1 over 9. And then you can write here D binom, and then 5 comma 5 comma 1 over 9. That is the answer. Okay. Now let us solve this problem manually as well as by using R. So let us do this one. Choose 5 comma 4 times 1 over 9 to the power 4. Then I have to write here 1 over 9 to the power 4 times 4 and then 5 minus 1. So that means 8 over 9. That means 8 over 9. Okay. Plus I have to 5 choose 5. Choose 5 comma 5. And then I have to multiply it by 1 over 9 to the power 5 times that is 5 choose 5, right? That is 5 choose 5, 9 to the power 5, and then 0. So that is equal to 1. That is equal to 1. So I have answered these things. Now I want to write it D binom. I want to do it by using formula 5 comma 4 and then point. No, it is 1 over 9. 1 over 9 plus I want to do it formula D binom and then 5 comma 5 1 over 9. Okay, so let me try the other way then. Maybe I write here other way. 5, that is fine. Okay, so when you write the formula, let me write it in there. Let me write it in there. This one Let me erase these things, rewrite these things, draw, erase these things. This should be other way. This should be here. It is coming as a 4. No, it is coming, let me see, 4. Yeah, 4 comma 5, 4 comma 5. So the formula is, this is the general formula, D binom. You put X, which is number of success, and then you put N, which is number of trial, then you use, this is the probability. This is the formula you should write down, okay? See the result matching between manual approach. This is the manual approach, and this is the formula approach is matching. So this is the correct formula. Understand? Can you see from here or not? Okay, sorry for hard time, right? Fine. Okay. Are you okay? Are you understanding? So binomial problem, okay? So rest of the problems, I'm not going to write these things. Take a look. I'm not going to write these things rest of the time, okay? Okay, I'm just going to write this formula. This formula I'm going to write. Okay, so come the next one. If the number of trials of a certain binomial distribution is 2 to 5, that means n equal to 2 and probability of success is 0.36, find the standard deviation. How can you find the standard deviation? Standard deviation formula is this: n, p, q, and square root. This is the standard deviation formula, right? So our n equal to what? 2 to 5. And probability of success is 0.36 times probability of failure is 0.64. That is the standard deviation, okay? Yes. Exam I will open on the next Thursday at 12:01 a.m. and it will be remain there up until maybe Sunday 11:59. Okay? Okay. So see, they have given their mean and standard deviation of a binomial distributions are 105. So mean of the binomial distribution is NP and standard deviation is NPQ. This is 105. Do you understand what I said? Mean and standard deviation. Mean equal to NP, which is equal to 100, and standard deviation equal to 5. Then they have asked us from their question is find n equal to what and find p equal to what. This is the two question, okay? So now if you plug np equal to 100 in there, then you will get what? If you put here np equal to 100, then you are getting 100 q, right? Equal to 5. This np I plug in there, I got 100 q. If you square it, then you get 100 q equal to 25. Okay, then q equal to what? You are getting 1 over 4. If you got q equal to 1 over 4, p equal to what? 3 over 4, right? Okay, now if you plug p equal to 3 over 4 in there, and 3 over 4 equal to 100, then n equal to what you are getting? 400 over 3, and then n equal to you are getting 400 over 3. Okay, so n equal to 400 over 3 equal to what? Let me find it. Okay, SQRT. Is there SQRT? No. Why I put here? Why I put it? This is not true. This is not true. n equal to 400 over 3. So it is 133, right? 400 over 3. So 133. So I can write here our n equal to 133, our p equal to 3 over 4. So our binomial distribution x equal to x, n equal to 133 c x, p equal to 3 over 4 to the power x, 1 minus 3 over 4 to the power 133 minus x. This is the answer. You are understanding, right? In this exam, how many minutes you will get? 40 minutes for 20 questions. Okay? 40 minutes for the 20 questions you will get. Okay, so I solve, let me solve one or two problems, then find the mean if the number of good pens is 20 and the probability of good pen is 0.8. So that means our results is NP is our mean. Okay. So the answer is good pen is 20 and 0.8. So 20 times 0.8, which is equal to 16. Clear, right? If a coin is tossed 4 times, find the probability that tail appears an odd number of times. Tail appear in odd number of times. Okay. So x equal to 1 and 2, odd number. So that means you want to get 1 and 3 because it is tossed 4 times, right? So that is the answer. You understand this, right? Odd number of times. Okay. The probability of a man hitting a target is 1 over 4. If he fires 3 times, what is the probability that he is hitting the target at least 1? So at least 1 means this one. At least 1 means probability of x greater equal to 1, which could be written as 1 minus probability of x equal to 0, right? Do you agree with that? At least 1 means 1 minus probability of no hit. So no hit equal to what? No hit equal to 1 minus d binom. And then he's hitting how many times? Let me see. He's 3 times 1 over 4. 3 times and 1 over 4. So d binom 0 and 3 times and 1 over 4. This is the answer. This is the answer. So let me see. This is equal to 1 minus b. 1 minus d binom 0, 3, 1 over 4. 0.57. 0.57 is the answer, okay? Okay. So probability that a student entering a university will graduate is 0.4. Find the probability that out of 3 students at the university, none will graduate. none will graduate. So that means 0, right? So that is the answer. Okay, so these are the some practice problem for the binomial distribution. There are 10 problems. Please solve it by yourself, okay? Okay, solve it by yourself. Be a master. 20 problems, you will get just 40 minutes, okay? Be a master on what? Try to read the 9-page document that discusses about the 6 probability distributions and associated R code so that you can quickly do this program. Understand, right? And I have shown you how to compute these things by using paper and pencil approach, right? How to do these things using like the paper and pencil can as well as by software. Okay. When we are a student, we have to use the calculator. Okay, so now let me close these things. Let me close these things. I want to now go to the another, where is my probability? Okay, let me go there. Geometric distribution, okay? How do you know a problem is a problem of geometric distribution? Yes. What? Yeah, you can during the exam you are allowed to use R. Yeah. Okay. So you remember your classmate Virgo, right? You Yugi. Yugi identified a problem. So when I make a one mean, I put to the another distribution. So there are two types of geometric distribution. Remember these things. Two types of geometric distribution. This is for the first time in my life. I'm teaching a class where my students showing back to me. Some of the people can think that they do not like their teacher. That's fine. So remember, two ways geometric distributions can happen. Okay? When last trial is a success. And your random variable could be number of trials or number of failures. Okay? The distributions that we have learned, these are all distributions for the random variable. What is the difference between variable and random variable? Random variable, each value has a certain probability to occur. On the other hand, variable could be any characteristics or phenomena that vary from person to persons, places to places, circumstances to circumstances. Okay. If someone asks you what is random variable and how does it differ from the variable, you must speak like that way. The random variable, each value of the variable has or within the certain range of the values of the variable has an associated probability. Understand? Which does not need to have for the simple variable. Variable is just which vary from characteristics that vary from person to persons, places to places, circumstances to circumstances is called random variable. Or is called just the variable. Okay. So now I have this is the formula where x is a number of trials. Okay. When 1 minus p to the power x minus 1 times p, here x stands for the number of trials. Okay. And in such a cases, probability mean is 1 over p and variance is q over p square. Okay. Standard deviation is written like this way. Okay. Now see, if a patient is waiting for a suitable blood donor and the probability that selected donor will be a match is 0.2, then find the expected number of donors who will be tested till a match is found, including the match donor. Okay. So there it is said find the expected number. When expected number, this word if you see in any question, immediately think that expected number means average. Understand? When you will see the two word expected number, expected value in this exam, immediately you will think that this is what the average is. This is what the mean is. Okay? Clear, right? Don't fall from the sky. So in this exam where I have discussed 7, 8 probability distributions and in for the random variable, if you see the two words find expected value or expected number, then you will immediately think this is nothing but the average or mean. Okay. So as it is saying, see, they have used here 1 over p. 1 over p use means number of trials, right? When number of trials, the mean is 1 over p. Number of trials. Where it is mentioned, if a patient is waiting for a suitable blood donor and the probability that selected donor will be a match is 0.2, then find the expected number of donors, like expected number of trials. Okay. Who will be tested till a match is found, including this. So 1 over p, which is equal to 5. So 1 over 0.2. So expected number donors will be tested till a match is found is 5. Okay. After that, suppose you are playing a game of darts. Okay. Game of darts, probability of success is 0.4. What is the probability that you will hit the bullseye on the third try? So that means 2 failure and third success, right? So 1 minus p to the power x minus 1 times p, which is giving you 0.144. Okay. 0.144. So geometric distribution is so easy. So if you want to use, if you want to find it by using R, I think you can do that. Just write here d geom, d geom. What was that one? I think you got it success at the third trial, right? So third trial you got the success. So 3 comma 0.4. Let me see whether it will give us the same result or not. Okay, I have put here 3. Let me put here 2. Yeah, if you put here 2, then it will giving you the answer. Okay. What is the difference between 3 and 2? 3 is the number of trials, but 2 is the number of there. I put here 3 number of trials, I got this 7, right? But if you want to use this R formula, you have to put here number of failures, not number of trials. Understand? Remember, right? Number of failures is 2. When I put, I got 0.144. But in the result, I got the 0.144 when we solved it manually. Manually means by God given hand. Understand? Which one? Three, six, eight. I think they maybe when they write it. So we can try, right? We can try, see which one is correct. A light bulb manufacturing factory finds 3 in every 60 light bulbs defective. So here you have to first find the probability of defective, which is 3 over 60. What is the probability that first defective light bulb will be found on the sixth one is tested? So sixth one is tested, that means 5 failure, right? 5 failure. So now 6 over 30, which is equal to 0.05. Let me solve it quickly by using this. So 5.05 0.05. That says a sixth. That means 5.086, 0.0386, 0.0386. So this is the correct answer. This is that is the typo, okay? So I got this one, 0.0386, 0.0386. Okay. Okay, so let me solve another one, and you understand why these things was derived, right? So this is the probability of finding defective bulb. Okay, after finding defective bulb, then you are finding that when the bulb were tested, a defective bulb was found at sixth try. Sixth try means first 5 is a failure. First 5 was found of the right good bulb was found in the first 5. Then sixth one was found to have defect. Okay. Let me solve this one, then we will move to another one. Find the probability density of geometric distributions if the value P is 0.42 and X equal to 1, 2, 3, and also calculate the mean and variance. Now, if X equal to 1, 2, 3, then you can write here. Okay, so I don't need to write in here. So P 1 minus P X minus 1 like this. If you write here X minus 1, then immediately explain X equal to number of trials. That will make the your professor, your advisor will be happy that you explain what is X is. Okay. On the other hand, if you want to write it here, X equal to like the 0, 1, 2, 3, because they mention here X equal to 1, 2, 3, you have to consider it as a trial, because there is no way this X could be failure, because failure could be 0. You can get success at the first trial, understand? When X value is given as a 1, 2, 3, 4, so you immediately think that X must be a number of trials. Understand? But if X was given 0, 1, 2, 3, 4, 5, then you said, well, since X takes value 0 value, and then X could be number of failures, because there could be 0 failure before getting success. That's the explanation, okay? So, and then it is written in this format, and then after that px was written like this way. Mean was found 1 over p, 1 over 0.42 like this, and variance equal to 1 minus um, variance equal to, they have written like that way, variance equal to q over p square. So q could be written as 1 minus p. So that is why they have written like this. Actually, uh, it should be written 1 minus p. It should be written in a bracket. Without bracket, it should be written like that, or it is not. So let me tell you, in both cases, whether, let me write it. This is the geometric distribution where x is the number of trials, and here mean equal to 1 over p, variance equal to q over p square. And this is a geometric distribution where p q to the power x, mean equal to 1 over p, and variance equal to q over p square. Okay, variance equal to q over p square. Okay, let me go to the negative binomial now. Where is that one? Negative binomial. So negative binomial distribution will be used. Negative binomial distribution will be used when you look for a specific number of successes. After a number of failures, like a number of uh, not consecutive failure. Suppose you are looking for 4 successes, but 4 successes is coming after 24 trials. Okay, after 24 trials, if 4 successes come, then this could be a negative binomial distributions. Negative binomial distributions, you are looking for a specific number of successes. You are looking for a specific number of successes, then it will be a negative binomial distributions. In my YouTube video, I have provided what is the difference between binomial and negative binomial distribution. Okay, my experiences is telling me that students mess up in distinguishing whether the problem is a binomial problem or negative binomial problem. Okay, binomial problem, number of trials are fixed. Okay, success probability P is fixed. Okay, you are given everything. A hospital has a 20 patients. Okay, a person has a 20 pen. Okay, 20 pen. Like number of trials is fixed. On the other hand, for the negative binomial distributions, the you do not know how long you will go to achieve your specific number of successes. The way data is generated is different from the way data is coming for the binomial distribution. The way data for the negative binomial distribution is generated is different from the data that are generated or that are coming from the binomial distributions. Okay, so let us solve problem. Here, so let me write the mathematical formula again in here, which is equal to x equal to x plus r minus 1 c r minus 1 p to the power r and q to the power x. This is the formula. And here x equal to number of failures, r equal to number of successes, p equal to probability of success, and q equal to probability of failure. These are the things provided to you, okay? From there, what we will look, we want to find the probability of number of failures. See, here x is the random variables. When we find this probability, we are finding number of failures to get this number of successes. Understand? So we are getting, like, in order to get our successes, what is the probability that we have? Okay. So let us solve problem in here. The probability of Mary solving a puzzle is 0.75. So the probability of solving this small p equal to 0.75, and then q is given 0.25. Okay, 0.75 and 0.25. Now the problem here is what is the probability that Mary solved puzzle correctly for the 5th time in the first 8 attempt? So in the first 8 attempt, he solved the puzzle 5th time. So 3 failures and 5 successes, right? Here, 3 failures and 5 successes. What can we do? We have to write here. According to that, x equal to, I have to put here 3, because x equal to number of failures. 5 is the success, 3 is the failure, minus 1 c, 3 minus 1, right? No, it is 5 minus 1. It is 5 minus 1. Sorry. It is 5 minus 1. And it should be 3. It should be 5. Okay. Let me erase these things right beautifully so that no confusion arise. So I can put here 3 plus 5 minus 1, 5 minus 1. And p equal to 0.75 to the power 5, and q equal to 0.25 to the power 3. That is the answer. Okay, so now if we want to solve this, this is come in here, choose. So 8 minus 1, that is 7, comma 4. Okay, 7, comma 4. 7, comma 4 times 0.75 to the power 5. That is equal to 5, and that is equal to 3. But I put there greater than sign, which should be replaced by this, and then this. This is the answer. Now I have to do D negative binom. I have to find there 5 comma 3, and then I have to put there 0.75. No, that is not the right one. Let me put there 5, and then there should be 8, I guess, and then 0.75. 25. 0.12, right? Okay, let me change it different way. Failure, number of success, then. Okay, so let me write it clearly so that you would not have trouble. Failure, success. So when you solve this problem, you write this code. N negative binom, you put their failure, which is equal to X, and then success, which is equal to R, and then P. So what we write in order to use the binom, this is equal to, I got 3, 5, and 3, 5, and 0.75. Okay. Okay. Okay, so we got this result. So 0.13, we got 0.127 something, right? We got 0.129, so 0.13 is the answer. Okay, so let us solve another problem in here, example 2. The probability of Alex hitting the target in archery is 90%. So success probability is given P equal to 0.90. So failure probability is given 0.10. Okay. After this, now I want to see what is the probability Alex hits the target for the second time in 4 attempts. So second time in 4 attempts. So here second times R equal to 2 and X equal to failure, which is equal to 2. So if I am asked to find this probability manually, the formula is X plus R minus 1 C R minus 1 P to the power R Q to the power X. Okay. So here 2 plus 2 minus 1 C2 minus 1 0.90 to the power 2 and 0.10 to the power 2. This is the answer. Okay. So which we could write like this way. 3 choose 1, 0.9 to the power 2, 0.10 to the power 2. Okay. So this is the answer. So 3 times 0.9, 3 times 0.90 times 0.90 times 0.10 times 0.10 equal to this. And then if I am asked to find this manually, I just need to put here 2, and I just need to put here 2 and 2, and then I just need to put here 0.90. Then answer is oh, oh, so why did I put there 8? It should be 3. It should be 3. It should be 3. Now the answer matches. Okay. Now the answer is matching. So before sitting for the exam, you should make it well set in your head when binomial distribution is appropriate. You should make it well set in your head when geometric distribution will be applied, when negative binomial will be applied. When these things will be well set in your head and Poisson distribution, then by reading the questions, you immediately have to, okay, let's go there. Let's go this R code. Let's go this R code. Write the R code, get the result, and check which multiple option you are going to choose. Understand? What are you going to do? Read the question and think, okay, this is the binomial. Read the question, think it is the negative binomial. Okay, read the question, think it is the Poisson distribution. It is the normal distribution. Normal distribution will be mentioned, but other distributions will not be mentioned in the question. Like with other than binomial, negative binomial, Poisson, geometric distributions, no mention of any of these distributions to use in the question. Okay. What? No, because last time everyone already got lot of points last exam. If I give extra time, it is not, because read the questions, immediately try to do it. Immediately 2 minutes is enough per questions. Okay. Okay, so this is done. Now come another one. Let us solve another problem. Or there is no other problem. There is no other problems in here. That's good. So in 1 hour, we solved 3 distributions. And let me go there again. And now I want to do Poisson distribution. Let me drink little water. Break, okay? take 5 minutes break, okay? I will start at 2:05. Okay, so now let me start now Poisson distribution. Okay, so remember Poisson distribution is actually coming from the binomial distribution. Poisson distribution has a mathematical formula like this. Poisson distribution has a mathematical formula like this. Minus lambda to the power x over factorial x. Okay, and then this, if you take a look at that, x takes value 0, 1, 2 up to infinity. Okay, this lambda is actually coming from binomial mean. Binomial has a mean n and p. N equal to what? Number of trials. That means number of cars that passes through a busy intersection, traffic intersection, number of vehicles, number of cars that pass through a busy intersections, and P is the probability of having an accident on that intersections. So in your exam questions, I might provide the value of the lambda, or I provide the number of cars as well as probability of accidents. If I provide that, from using that, you have to compute the lambda first, okay? Lambda is the rate of accident, and after that I can say compute the probability of having 4 accidents. You understand, right? So this mathematical formula, no human brain can intuitively think how this formula works to compute the probability of an accident, or for an like call drop, or for a like something unusual. Okay, so this distribution is appropriate when number of trials n is very big, okay, and the probability of an event is very low. Under these two conditions, these distributions can be applied, and there is no way No human being, no human brain can intuitively think the existence of this function unless he can see the mathematical derivations of this. It is coming from binomial distributions. In binomial distributions, when n equal to lambda is assumed and number of trials x goes to infinity, probability of success p is very small, then this distribution is coming from a mathematical derivations from the binomial distributions. So with that being said, now let me take you to a binomial distributions, Poisson distributions problem, okay? Take a look. If 2% of the product in a company are defective, find the probability that less than one item is defective in a sample of 100 items. In a sample of 100 items. So see, so P equal to 2 over this, like this, it is given in there. This is what they are. And now NP is computed. NP is computed like uh, N times P equal to 2. So based on that, they are computing this formula. So they have given N equal to 100 and P equal to 0.02. Now, in order to use the lambda, you have to use NP. NP, if you use, then you are getting here 2. This is what the lambda is. Now, formula for find the probability that less than one item is defective. Less than one item is defective, which could be obtained. Find the probability that less than one item is defective. Less than one item is defective means probability of x equal to 0, right? This is less than one item, right? Do you understand these things, what I write? Less than one item means 0 item is defective, right? Less than one item defective means 0 item is defective. So that means x equal to 0. If you want to compute this, you have to come in here and then you have to e to the power minus lambda, which is equal to 2, and 2 to the power 0 divided by factorial 0, which is equal to e to the power negative 2, and e to the power negative 2 equal to exp, exponentials of negative 2 would be this 0.135. So let me see the answer. E to the power negative 2. Are you seeing that? You see that, right? E to the power negative 2. So the next one, if the probability of choosing incorrect answer in an exam is 0.01, see, probability is given, determine the chance that out of 500 students, more than one will choose incorrect answer. More than one will choose incorrect answer. So let me write it. more than one will choose incorrect answer. More than one will choose incorrect answer. So that is 1 minus probability of less equal to 1. So that means you are finding 1 minus probability of x equal to 0 minus probability of x equal to 1, right? Are you saying more than one will choose incorrect answer? More than one. More than one will choose incorrect answer. So then if you want to do these things, e to the power minus lambda, lambda to the power x equal to 0 divided by factorial 0, then you can put it to the power minus lambda, lambda to the power 1 divided by factorial 1, right? Now what is lambda? We have to find the value of the lambda. Lambda is the mean. Lambda is the mean which is equal to NP. So there are 500 students, probability of choosing the probability of choosing incorrect answer in an examination is 500 times 0.01. 0.01. Okay. So then if you multiply these things, I think it will be 5. Come in there. 500 times 0.015. So we have value here as a 5, right? So now we want to put here 1 minus e to the power minus 5 and 5 to the power 0 divided by factorial 0. 1 minus 5, 5 to the power 1 divided by factorial 1. Times 5. Okay, so let me compute it manually and then I use the R code so that we would not have a problem. 1 minus exp of negative 5 minus 5 times exp of negative 5. Right? This is the answer. Now I want to do 1 minus d poise, and then I have to put here 0, and then rate is 5 minus d poise 1 comma. Are you seeing the same results, right? So take a look at the R code that I have provided. Okay. You have to take this exam in next class during the class time. Give it try. I want you to take this exam class 10 next week. Yeah. Yes or no? And then, okay, then final comprehensive exam in the in class, okay? What?
Wait, let's keep it. Let's keep it at the very beginning.
Okay. Okay, then next Thursday, I will maintain office hour during class time. Okay. So no class next Thursday. Okay, so Poisson distribution is done. Now let's go to the normal distribution. Let me see if I can solve another different types of problem. It is a 0.906, like 0.906, like yeah, 0.96, 0.96. Yeah, that's good. Okay, so a man can send an email on average 2 emails per hour. What is the probability that the man send no email in a given hour? So mean equal to 2, which means rate, which is equal to 2, lambda value equal to 2, and then no email means x equal to 0. So this is what the value is, probability is. Find the mean of the Poisson distribution given that variance of the Poisson distribution is 4. Yeah, I think that. So here is some problems. So practice this problem, okay? Practice this problem and try to become efficient in R code. So discrete uniform, you can just read 1 or 2 problem. If I give any problem from discrete uniform, this will be very simple one, okay? This is the very simple one, discrete uniform. As I mentioned, it looks like this way. So die tossing experiment, die something like this. So read this document. I did not discuss that much of this one. Okay, let us solve some problem from normal distributions. So take a look. When I discuss the empirical rule, I said within one standard deviations from this mean 68%. Are you saying this is 68%? Within 2 standard deviation from mean, if this is the mean, 2 standard deviation, 95%. Within 3 standard deviation from mean, 99.7%. When? Oh, if you have a data, that data is quantitative data, that quantitative data you created class interval, and you put the frequency, and then you constructed the histogram. After constructing the histogram, if you draw a smooth line by joining the top middle point of each bar, then if the smooth curve look like symmetric, then only this rule will be applicable. Understand? Okay. You have a quantitative data. From the quantitative data, you construct histogram, and you add the top middle point of each bar and add by a smooth curve. If that smooth curve looks like this symmetric, then 68% data fall within one standard deviation. This is the mean, and this is the one standard deviation. One standard deviation added with the mean, it jump in right. Subtracted standard deviation from mean, it jump to the left. Okay. So within one standard deviation, 68%. Within two standard deviation, 95%. Within three standard deviation, 99.7%. That is the empirical rule. But the question is, how do I know 1.2 point standard deviation, 3.9 standard deviation? In order to know, in order to do those type of problem, we have to use normal distributions. Okay? Is this the reason that it is not? Okay. So now, this is the normal distribution table. I discussed these things in details. Now, so this is what the, okay. In normal distributions, let us solve these things. A normal distribution has a mean of 50 and a standard deviation of 5. Let us solve these 5 problems. Then maybe that is enough for. So now normal distributions, they are saying the problem number 1, we are given mean which is equal to 50 and standard deviation sigma equal to 5. These things is given. And then you are asked to compute what is the probability that a randomly selected value from this distribution is less than 45. So they are asking you to find the randomly selected value that is less than 45. This is what they have asked you to find. In order to find this one, let us draw the figure. This is the normal distribution. In this normal distribution, if I want to put here mean equal to 50 and less than 45, which is equal to this, so you are asked to find, this is the, again, this probability means percentage of frequency. What is the percentage of frequency that falls below this, which you can find just by writing P norm and then you can write here 50. You understand this, right? Okay. So this is the way you can solve it. Now, let me solve it manually as well as by this approach. So first apply directly the formula approach. P norm 45 and 50 and then mean equal to 5. That is the answer equal to 0.1586, right? 0.1586 is the answer. Here 0.1586 is the answer. Now let me show you one thing. How did we solve this problem when we were a student? We write it like this way. Let me write it. We write it like this way. Probability of x minus mu over sigma less equal to 45 minus mu equal to 50 sigma equal to 5. So In left hand side, I subtracted the mean. In right hand side, I subtracted the mean. In left hand side, I divided it by sigma. In right hand side, I divided it by sigma, which is equal to 5. So now I have this becomes Z. Z is a standard normal distributions. I provided the handout. On that handout, I clearly mentioned this. And then it has reduced now negative 5 over 5, which is equal to negative 1. So now this distribution reduced to like this way. Previously mean was 50, now mean is 0. Previously 45, now it has become negative 1. Here is the negative 1. So negative 1, how can I find negative 1? This negative 1, if we find from the table, which is equal to 0.1586. How? How? Take a look, 0.1586. Oh, here they did not give the negative value in there. But let me find the here. Negative 1. Negative 1 equal to 0.1586. Did you see that? 0.1586, okay? 0.1586. This is the 0.1586. So negative 1 here. Are you saying 0.1586, right? So 0.1586. So you have seen that 0.1586. Now, as it is negative 1, I can also change it to negative 1 and I can change it to negative 1, and then I can negative 1, I can change it to 0, and it is 1. Now see exactly same thing. 1 is in the X scale, another one is in the Z scale. When mean equal to 0 and standard deviation equal to 1, that is known as the standard normal distribution. Okay? That is known as the standard normal distribution. Okay, one problem is solved. Now let me take you to the next problem. Next problem. If a data says follow a normal distribution with a mean of 100 and a standard deviation of 50, what is the z-score for a value of 130? Instead of normal distribution, now they ask you to transfer the value in the z-score format. Okay, so come in here, z-score formula. Z-score is written like this way: x minus mu over sigma. We are given in the question mu equal to, we are given in the question mu equal to 100, standard deviation equal to 15. Mu equal to given 100 and standard deviation sigma equal to given as a 15. What is the z-score for a value of 130? Now they are asking you, okay? So now if you want to do 130 minus 100, divided by 15. So it is equal to 2. Okay. So now they ask you explain about this Z score. Okay. So Z equal to 2. Within 2 of Z score, what percentage of frequency fall? Within 2 standard deviation? 95. Z equal to 0, 2 right, 2 left, right? So there is a X scale where mean equal to mu and standard deviation is equal to sigma. There is a Z scale where mean equal to 0 and standard deviation equal to 1. So Z to 2 means 2 standard deviation. Z to left 2 means negative 2 standard deviation. Okay. So we need to understand. They ask you explain these things. So your explanation is that. So within 2 standard deviations from the Z scale of 0, 95% of the frequency fall or the 95% probability. I like your class. Did you bring it from your home or from here? You brought it from Nigeria? Well, very beautiful. But my one is from USA. I got it in 2015 by spending $490, but it's giving me 10 years service. I'm super happy. You understand, right? Normal distribution has 2 types, actually 3 types. One is standard normal, and another one is normal in the X scale. Another one is sampling distribution, which is in X bar scale. Z scale, X scale, and X bar scale, okay? This is the second problem gone. Now come to the third problem. Given a normal distributions with a mean of 70 and a standard deviation of 10, find the probability that a randomly selected value falls between 60 and 80. So 70 and 10. So question number, that one, given mu equal to 70 and standard deviation equal to 10, and then question is asking you the randomly selected value falls between 60 and 80. Falls between 60 and 80. Okay. So if someone asks me to draw the graph, I will draw the graph like this way. And it has a mean of 70 in here. And then they are asking that it ranges from 60 to 80. Like this, 60 to 80. Okay. Which is just, if you are good in R, just write P norm 60, 70, and 10. Sorry, 80. Because you are subtracting this area, you are subtracting, let me use different color. You are subtracting this area, you are subtracting this area, which is this probability of P norm 60, 70, and then 10. You are subtracting this red area from this blue area, from this green area. What is green area? Green area is this. Okay. So green area is this one and red area is this one. So if I want to write the R code, I have to go there. I have to write here Binom 80 and then mean equal to 70, standard deviation equal to 10 minus Binom 60 and then 70 comma 10. This is the answer, 68%. That means within one standard deviation, okay? Within one standard deviation. Number 4, in a normally distributed data set with a mean of 100 standard deviation of 10, what value correspond to 98th percentile? Okay. In normal distributions, there are always two types of problem, right? One is state problem, which I call as a state problem when you are asked to find the probability or percentage of frequency. Probability or percentage of frequency are the same thing. Okay. So this is what I call as a straight problem. So you are asked to find the probability. On the other hand, when probability is given and you are asked to find the values or quantiles, that is called the inverse problem. So problem number 4 is the inverse problem. Okay. So other way you have to solve. Instead of P norm, you have to use Q norm. That means quantile. So what is the question? In a normally distributed data set with a mean of 80 and standard deviation of 10. So in this case, mean of 80 and standard deviation of 10, they have asked you find what value corresponding to 98th percentile. What value correspond to 98th percentile? Like this, less than equal to what value of A will give you 98th percentile. Are you understanding the equation? So if you ask me to draw the figure for this, okay, then 98th percentile, this is equal to A and this is equal to this is equal to 0.90. This is equal to 0.90. Then in order to find this value, let me show you how we solve it, okay? How we solve it 20 years ago, 25 years ago. So we solve it like this way. Probability of x minus mu over sigma less equal to a minus mu over sigma equal to 0.90. Then this is my z, and then I can put there a minus mu, which is equal to 80, and this is equal to 10, right? 10. So I put here 10. 10 equal to 0.90. Now I should go to the table, go to the Z table. I go to the Z table. After going to the Z table, I can find probability of Z less than a value equal to 0.90. So what is that value? That value is, go to the table. Here is the table, 0.90. I want to go and find to the 0.90. Okay, so I have to. Okay, so take a look at that 0.90 is coming. Point 0.90 is coming 1.28. Are you seeing? See, this is the closest one to 0.90, okay? This is the closest one, which is equal to 1.28. 1.28. Are you seeing? 1.28. 1.28. 1.28. Are you seeing that? 1.28. So I have to plug it in there, 1.28. I have to plug there 1.28. 1.28. Now see, this equation and that equation are matching. This is right hand side, this left hand side is this. So now I can put here a minus 80 divided by 10 equal to 1.20. Now a equal to what? A equal to 12 plus 80, which is equal to 92. Which is equal to 92. No, this is what we did it. Now see, when I came in 2006, I was learning all of these things, mathematical statistics. In first year class, I think a guy, he's from maybe Latin America. And he was tired of seeing professor writing all the codes. And he said, just suppose there is no computer system, there is a nuclear war, people die. And how can we do all of these things? Then professor said, well, not this question about like matrix algebra. What is how to compute this thing? Professor is doing all the computation matrix algebra. No, I want to take a look at everything, how to compute this inverse matrix by like this. So professor said that well, next day I will come and show you. And then she spent like half an hour to show us. So when general inverse does not exist, how to compute the inverse? Professor was computing those things by using software, computer. He's asked this question. So similarly, if you ask me these questions, that is the way our forefather computed this. So the table that you are saying, this table, many people together sit there. This is the values they have computed when like 100 years ago. Okay, and by doing just the numerical integrations, they computed these things. Many people, British government gave a lot of funding, thousands of people working together days and nights to create a table. There is also a book. That book has a normal table, log table, exponential value, binomial value. This lot of people together, British government gave money and then they created that table. And that table was exported rest of the world. Okay. Okay, so now I solve this by using this approach. Now I want to solve this by using software approach. Now in order to solve the software approach, I just need to go to the Q norm, and then what was the probability? 0.92, right? So 0.90, and then mean equal to 80 and standard deviation equal to 10, and then I got 92. Are you seeing 92? This is the paper and pencil approach, and that is the approach we use by using software. Okay. First approach, yeah. But you have to understand like the what is going on. Okay. That is why I draw the figure. Each of this problem I draw the figure so that you would not have a problem. Let us solve another problem. So this is called the sampling distributions problem. Okay. So a sample of 30 students. So this is the sampling distributions problem. So this is a so sampling distribution problem. A sample of 30 students. A sample of 30 students has average score of 78. Average score of 78 with standard deviation. Standard deviation 10. Oh, sorry, 78 with standard deviation of 12. Okay, this is what we are given. Assuming distribution of test score, what is the probability the sample mean score is greater than 82? Sample mean score is greater than 82. Probability of, instead of x, now it is x bar. Okay, greater than 82, which could be written as 1 minus probability of x bar less than 82, which could be written as 1 minus p norm 82, mean equal to 78, and standard deviation equal to 12 over square root of 30. That is the only difference. Understand? Previously, when it was asked x is greater than, I just put there standard deviation 12. But now it is x bar, right? X bar. When x bar, it is standard deviation equal to like standard deviation divided by square root of n. Okay, so that let me write it in here so that you will not forget. Standard deviation of x, if someone asks me standard deviation of x, standard deviation of x equal to sigma square, sigma, okay, just sigma, and standard deviation of x bar equal to sigma over square root of n. Okay, so because of this is x bar, excuse me. Thank you. So this is x bar. So that is why we put here sigma over square root of n. Okay. Now let us solve this problem. 1 minus p norm I want to find here 82. Our mean equal to 80. Standard deviation equal to standard deviation 12 over square root of 30. 0.8193. Yeah, I'm coming. 0.8193, which is equal to 1 minus this 0.1806. 0.1806. No, no, no. Q norm is to find this one. Don't mess up anything. Q norm is to find this one. Now, this one given, I was asked to find this one, right? Now, this one is given, I was asked to find that one. When probability was given, and you are asked to find the values of the variable, either x bar or x, that is called the inverse problem. You are finding quantile. You are finding quantile, you are finding percentage value. Okay. But when quantiles or percentage values are given and you are asked to find the probability, that is called the straight problem. Inverse problem means this one is given, that one you are asked to find. Then you will use Q norm. Okay. Okay, do anyone have any question? I have 45 minutes remaining. So one set of problems, there is a uniform distribution, okay? Read that document. A question coming from there. One thing I did not discuss thoroughly, but I really want you to practice this so that I want to test whether how much you are good in solving uniform distributions. The link that I have provided, question will come from there. Okay. With a little change of the wording, sentence or number, but the question will come. Yes. 40 minutes. Time was not shown. But the first one, first exam has the time showed up? Oh, okay. I will. But it is 40 minutes, okay? And you see, it is just writing one line of code, right? Remember, read the question, try to understand what type of problem it is. Okay? And then be super good in R coding so that you can find. You got 45 minutes of your valuable life free. But I'm going to stay here. If you have a question, you can ask me. So are you learning something from my class? Sure? But your major is biological science, right? But see, these statistical things you have to do. You have to do a lot of testing, confidence interval, all of these things you will have to do. Down the road, you will have to do, definitely. Sorry? No, after, okay, she asks a question. After this one, then we will go the confidence interval test of hypothesis. That one we will have an exam and then comprehensive. So many exams. Yeah, that is, but I am giving you part by part, small by small. Okay. And then I am covering a lot of materials. This is true, but giving 12-page, 13-page document, all the materials I have put there. If I give you like, buy this book, read this table, all of these things, so that does not work in that myself. I said that all the knowledge that I have, I will be specific, give them little knowledge, and then given one after another exam and then comprehensive exam. I think their university has declared a date according to that date. Okay, there will be 50 questions. 50 questions.
We have 3 more exams to go, right?
Yeah.
And how long will you give us?
But remember, you do not have any. I have given you project, like very simple project, and then no homeworks, nothing. I ask you read this again and again and again and again.
And
So
how much time will you give us on the final?
that is a good question.
Please give
50
us,
questions, maybe 100 minutes.
please give us a little more.
130.
A little more.
You know, when I am consistent with all the sections, right? But I see when I give lot of time for the 20 question, 100 minutes, almost everyone is scoring.
Yeah, no, 100 minutes is too much. Yes, but
You understand?
maybe we can
And now
do a little more.
I was asked by the department chair and like the so that from next I have to use like the what it called like proctor exam. So when you will log in, you will not have a right to do anything. You have to use the computer.
What about the R?
Maybe next time I will ask them. You have to use the maybe R or maybe you can use the your calculator and table.
No, I need R. Like I cannot do it without R.
Okay. The problem is if student do not learn something from the class, then it will bad for all of us, right? If there is a way to do bad thing, then it is not a good. So that's the reason. But anyway, let's see.
But yeah, please allow us to use R. We need R.
Okay. Okay.
Like,
Mhm.
I don't think I'll be able to like even with the table. It will take me more than 2 minutes. It will
Okay.
take me like at least 5 minutes to do it by hand.
Okay.
Right? Yeah.
Mhm. সাকিব, আসসালামু আলাইকুম। আলহামদুলিল্লাহ। তোমার চাকরি কেমন চলতেছে ইস্টার্ন ইলিনয়তে? ও তাই ওদের ওখানে তো আবার জবের অ্যাডভার্টাইজমেন্ট দিলে দেখলাম, এখানে কাটাকাটি চলতেছে, রাইট? ও আচ্ছা আচ্ছা আচ্ছা, বুঝছি। আমাদের
আগে থেকে অপশন দিছে আর কি, মানুষ যাদের অনেকদিন হয়ে গেছে তাদেরকে একটা 7S প্যাকেটের অপশন দিছিল আগে থেকেই।
আচ্ছা,
দেখতে পারেন আর কি। আপনার কি অবস্থা স্যার?
আমরা তো এখন দুইজনে এখানে মাস্টারি করি ওই ইলিনয়তে। তো আমরা তো দুইজন টেনিউর ট্র্যাক ছিলাম, ওই দুইজনকে তো না করে দিল। এরপরে আরেকজন টেনিউর ছিল, পার্মানেন্ট ছিল। ও ওইগুলোর অবস্থা দেখে চাকরি ছেড়ে চলে আসছে আর কি। তো ওখানে এখন স্ট্যাটিস্টিক্স এর আছে মাত্র একজন। তো এখন ওই গত কয়দিন আগে দোহা আমাকে ফোন করে বললো ওরা ওই আমাদের পজিশনে আবার লোক হায়ার করবে আর কি। তা আমি তো এই বছর ওখানে অ্যাসোসিয়েট হয়ে যেতাম আর কি, বুঝছো? এই বছর আমি ওখানে অ্যাসোসিয়েট হয়ে যেতাম, এই আর কি। হুম। না ওরা ধরো না আমাদের লোকজন না, কিন্তু আমাদের বাংলাদেশে তুমি দেখো ওই যে ডাকসুর টাকা খায় ফেলেছে, রাইট? তুমি চিন্তা করে দেখো, তুমি তো এখানে লেখাপড়া করছো, তুমি কতগুলো টিচার দেখছো, আর বাংলাদেশে দেখো দেখি 35 জন 36 জন টিচার। তুমি এখানে দেখো, আমি এই সেমিস্টারে 4টা কোর্স পড়াচ্ছি, আগামী সেমিস্টারে 4টা, সামারে একটা, 9টা কোর্স। তার মানে বাংলাদেশে আমি সরকারি ইউনিভার্সিটি চাকরি করছি, বছরে একটা কোর্স পড়াইতাম সারা বছর মিলাইয়া। রাষ্ট্রীয় সম্পদের যে অপচয় বাংলাদেশে, একটা পলিটিক্যাল সায়েন্স, এখানে পলিটিক্যাল সায়েন্সের ডিপার্টমেন্টে 4-5 জন চালায়, আমাদের 35 জন টিচার। আমি তো মনে করছি একবার সুন্দর করে একটা ভিডিও বানাইয়া একটা মানে মানে কম্পারেটিভ দিব, চিটাং ইউনিভার্সিটি পলিটিক্যাল সায়েন্সে এতজন, ক্যালকাটা ইউনিভার্সিটিতে এতজন, আমেরিকা ইউনিভার্সিটিতে এতজন, স্ট্যাটিস্টিক্সে এতজন, বাংলাদেশের ইউনিভার্সিটিতে অনেক বেশি লোকজন আর কি, বুঝছো ব্যাপারটা? কিন্তু আমেরিকাতে তো ওরা বাজেট টাজেট দেখে তারপরে দামাদাম দামাদাম সাইজ করে দেয়, বুঝো না ব্যাপারটা? পরে আবার লাগলে নিবে, এই আর কি। হ্যাঁ হ্যাঁ। তো তারপরে দেখো না, বাংলাদেশের যে ইউনিভার্সিটি গুলো, পাবলিক ইউনিভার্সিটি গুলোতে কোনোখানে অ্যাডভার্টাইজমেন্টে বলে নাই যে তোমাকে 2টা কোর্স পড়াতে হবে, মানে কোনো কিছুই নাই। 2টা কোর্স পড়াতে হবে, বছরে এতগুলো পাবলিকেশন করতে হবে, বা তোমার এটা করতে হবে, কোনো কিচ্ছু নাই। অফার লেটারে কিছু নাই, তারপরে চাকরির অ্যাডভার্টাইজমেন্টে কোনো কিছু নাই। এখানে তো অ্যাডভার্টাইজমেন্ট হতে শুরু করে সমস্ত, কেন সমস্ত কিছু নির্ধারিত। আমি বলে বাসায় সহ সমস্ত কিছু মিলাইলে আমি প্রত্যেক সপ্তাহে 70-80 ঘন্টা কাজ করি, বুঝছো? এই আর কি। এখন তোমার কি দরকার, তোমার হেল্প কি দরকার? আচ্ছা আচ্ছা আচ্ছা
এইচারে কোথায় কোথায় পিএইচডি এর অপশন গুলো আছে।
আচ্ছা
আমার এখানকার যেটা আমি করতেছি, এখানেরটাতে আসলে আমার মেজর হচ্ছে স্ট্র্যাটেজিক ম্যানেজমেন্টে।
আচ্ছা
তো আমি আসলে ঠিক করতেছি এইচআর এর দিকে কোনোভাবে যাওয়া যায় কিনা।
আচ্ছা।
তো আমি ওই দুইটা ইউনিভার্সিটিতে,
হুম
একটা নিউজিল্যান্ডে
হুম।
আর একটা হচ্ছে আপনার এখানে কানাডায়,
আচ্ছা
কানাডা ইয়র্কে।
আচ্ছা
তো এই দুইটাতে আমি ট্রাই করতেছি আর কি, যদি যদি লাগা যায় এরকম একটা সিচুয়েশন।
আচ্ছা
তো আমি আপনার কাছে স্যার একটা ওই যাবে ওই রেকমেন্ডেশনের জন্য,
আচ্ছা।
ওইটা যাবে। আর আমি এখন মানে মোটামুটি কাউকে এখনো কারোর সাথে শেয়ার করি নাই, বাট আমি লোপা আমরা আসলে মোটামুটি এখন কনসিডার করতেছি এখান থেকে মুভ কর।
ও আচ্ছা।
আমি আসলে এই মানে কেওস বেশি হয়ে যেতেছে এখানে।
ও আচ্ছা, তার মানে
এখন আমি প্রাইমারি না রেখে আমি এখন ওই এক্সপ্রেস এন্ট্রি কানাডা এইসবের দিকে ট্রাই করতেছি আর কি।
ও আচ্ছা আচ্ছা আচ্ছা। হুম। না, আমি রেকমেন্ডেশন লেটার আসলে আমাকে তোমার ইয়াটা পাঠিয়ে দিও, কি জানি বলে ওই যে তোমার ট্রান্সক্রিপ্টটা বা তোমার সিভিটা পাঠিয়ে দিও। ওইটা দেখে আমি একটা রেকমেন্ডেশন লেটার লিখে দিব আর কি। তুমি অন্যান্যখানে ধরো এই যে সাউদার্নে কোনোখানে এরকম দেখতেছো না হিউম্যান রিসোর্সেস, জর্জিয়া স্টেটে দেখছো? জর্জিয়া স্টেটের কি অবস্থা? ওখানে ওদের কিন্তু বিজনেস স্কুল বিশাল ভালো আর কি, বুঝছো? ও আচ্ছা আচ্ছা আচ্ছা। হুম হুম
তো আমি এখন যেটা চিন্তা করছি যে আমার যেখানে আমি এখন আছি আমার ইউনিভার্সিটিতে আমার কোর্স গুলো মোটামুটি সব হয়ে গেছে।
আচ্ছা
তো সামনে আমার হচ্ছে কম্প্রিহেন্সিভ আর রিসার্চটা বাকি।
আচ্ছা।
তো যদি কোনোভাবে ক্রেডিট ট্রান্সফার করা যায়
হুম
তাহলে করলাম, আর না হলে তো নাই।
হুম
বাট আমি যেটা বুঝতেছি স্যার এখন আসলে আমাদের সাথে যারা আছে
হুম।
এদের আসলে এই পাগলের সময় আসলে এখানে থাকাটা খুবই কঠিন হয়ে যাবে দিনকে।
এখন ও তো আগামী কিছুদিন পরে তো চলে যাবে গা, এবং মামদানি যদি ইলেকশনে জিতে যায় গা, বুঝছো?